Bonjour à tous. Hello, everyone. My presentation focuses on a multidisciplinary project in Fox Creek, Alberta, that aims to assess the environmental cumulative effects as Fox Creek has been one of the most active regions for oil and gas production in Canada over the last 50 years. Okay, so I'll skip the abstract for today. This project, as all multidisciplinary projects, involves many people, and we currently have 4 grad students. This study area is located just southwest of the town of Fox Creek in west central Alberta, where many forest fires are ongoing. It extends over 700 square kilometers. This area is mainly industrial, and this is why it was selected for this study. Only in this limited study area, there are over 800 oil and gas wells and several thousand kilometers of linear features. The regional bedrock aquifer is located at the northern edge of the Pascapou Formation, shown in yellow here, which is the most important groundwater supply in the province. It is a non-marine unit that is a complex succession of interbedded mudstone and siltstone with sandstone channels that is known to contain some coal seams. The Fox Creek project has 3 objectives related to the 3 sources of funding. First, to characterize the shallow bedrock aquifer located in the Pascapou Formation. Second, to investigate the integrity of the intermediate zone that controls the vulnerability of superficial aquifers to potential contamination that could come from activities at depth. And the third objective is to assess environmental cumulative effects. Last summer, groundwater from the 9 monitoring wells drilled in 2020 and surface water were sampled. In the fall, 3 core drillings were carried out in addition to the 9 monitoring wells that had been drilled using a conventional technique with which only cuttings can be obtained. In addition I just said that, sorry. So the objective this time was to obtain data or information on vertical hydraulic gradient and water chemistry, but also to obtain cores for density, porosity, permeability, and S&P wave velocity analyses to support the borehole geophysical interpretation, as well as for rock geochemistry. And eventually, cores ended up being also useful for thin sections. The cores we obtained from the 100-meter borehole very well illustrated the great heterogeneity of the Pascapou Formation and its highly variable degree of consolidation. I'll come back to that in a second. Because very large amounts of water were needed during drilling, groundwater from these 3 new wells was sampled only in January. A first visit by the students studying vegetation recovery, Haley, also took place last October. And another student, Daniels, has gone in the field almost on a monthly basis since the beginning of his master's degree to collect data on his 5 paired sites, including disturbed and undisturbed areas. Disturbed areas here mainly correspond to seismic lines. The work has included collecting data or samples from lysimeters, soil moisture sensors, rain gauges, and rain collectors for frost-free days, and from the snowpack to obtain density, thickness, and chemistry during the winter. So I'll now very briefly present some of our results. Sandstone intervals in the Pascapou Formation vary from compacted to unconsolidated, as you can see on the pictures. So the question was, what is the cause of these friable sandstones? And since the aquifer capacity is related, among other things, to the degree of cementation, this has thus important implications for the understanding of groundwater flow in this area. Based on thin sections, it was found that an early clay coating on particles during the Paleocene allowed the preservation of the framework. Then significant dissolution of unstable minerals generated secondary porosity with minimal later cements. Later, exhumation to surface conditions during Eocene resulted in major freshwater circulation in the new fractures and pore space, resulting in significant late dissolution of minerals and cements, producing these friable to unconsolidated sandstones. The 1D Shaw model that simulates heat and water movement through plant cover, snow, and soil was used to simulate the different components of the water budget in disturbed and undisturbed areas for an upland site and a lowland site. At this time, only the growing season was simulated, but this period shows that evapotranspiration in the upland site generally equals or exceeds precipitation. For the lowland site, the results show that the disturbed area has an evapotranspiration value nearly half that of the undisturbed area, keeping the soil very moist, likely preventing the vegetation from recovering to its initial state. The moisture in the shallow soil layers in this area is thought to come largely from snowmelt and a few large rain events. Only a small amount of water can infiltrate below a few meters and eventually reaching the water table due to the low permeability of the superficial sediments. A few wells were found to contain small concentrations of dissolved methane and all had a microbial origin, so that's very good news. Based on different lines of evidence, including water types, we believe that there will be two distinct systems in the freshwater Pascapoo aquifer, a local, shallow, unconfined system, probably from 0 to 30 or 50 meters deep, that is connected to the hydrographic network, and a less local, deeper confined system that is disconnected from the streams. This is supported by the general chemistry data, but also by the water levels in our wells and statistics from the provincial database that show that the mean static water level in wells across the study area increases with well depth. This is also supported by dating data. In these wells, groundwater generally contains very little or no tritium and showed uncorrected radiocarbon age values between 5,000 and 10,000 years in shallow upstream wells and larger than 10,000 years in deeper wells located in the middle and downstream parts of the watershed, indicating that the groundwater is surprisingly old for this small watershed. The radiocarbon data were very recently corrected for carbonate dissolution, and years were all reduced by 20 to 70%. The student, Manon, is also currently working on the isotopic ratio of strontium to assess the possibility of upward migration from deep units. So based on the facts that high yields are available in the Pascapoo Formation, vertical recharge is low, varying from 0 to 70 millimeters per year. Some sandstone intervals are barely consolidated or unconsolidated, and that we found relatively large radiocarbon age values. We believe that a significant contribution of water would come from the Rocky Mountains, from the foothills, in fact. To study surface water-groundwater interactions, a model in the coupled surface water-groundwater CAFE model was developed using the uppermost 45 meters of the study area, which include superficial sediments and the unconfined part of the Pascapoo Formation. This model was developed using a 200-meter resolution and the hydraulic conductivity distribution obtained with the hydrogeological model that was previously developed in FEFLOW. The student, Barbara, recently ran a 50-year simulation in order to reach steady-state conditions. The graph to the right shows some of the model outputs over time that are currently being investigated, such as atmospheric forcing, the actual flux that crosses the ground surface to reach the subsurface, overland flow, return flow, groundwater recharge, and outlet discharge, into streams. For the study on the evolution of landscape over time, air photos from the 1950s and satellite images from 2020 were used. Many classes or categories were used for this comparison, such as cut blocks, forest, wetlands, and different types of linear features. As the table and map at the bottom of the slide show, the reduction in forest shown in red on the map is quite significant, minus 220 square kilometers, so more than a bit more than 35%, which is roughly equivalent to the space lost to cut blocks. Linear features, although limited in extent because they are very narrow, are everywhere in the study area, impacting not only the water budget, but also the predator-prey dynamics, which is not in favor, as you can imagine, of caribou, to name only this animal. These long open pathways make caribou very vulnerable. The project on vegetation recovery that just started last fall will use multiple characteristics of vegetation on reclaimed pads, well pads, and adjacent reference forest to evaluate recovery on of the understory plant communities. Fieldwork this summer, let's cross our fingers, will involve measuring and sampling vegetation to quantify species richness and diversity, plant height distribution and horizontal cover, and functional trait values. Data for reclaimed well pads of different ages will be analyzed to visualize characteristics of estimated well pads and to track changes in the plant community over time compared to a reference condition target. The findings of this project should aid in broadening our knowledge of ecosystem functioning post-disturbance and inform forest management and well pad reclamation. Finally, the objective of this general study on cumulative effects was to provide constructive, practical, and realistic recommendations to address the challenges and obstacles associated with cumulative effects assessments in Canada. To achieve this, 15 semi-structured interviews were conducted with practitioners and federal government employees, and 5 focus groups were conducted with First Nations community members and environmental advisory committees. Participants were selected from across the country, as you can see on the map, to make the results as representative as possible. 10 key recommendations emerged from this study as most relevant to improving cumulative effects assessments. Most of the recommended improvements involve governments, which will therefore need to be willing and prepared to provide considerable funding and make legislative changes. I have put on this slide some of the most important for those who will want to read them later, because I'm pretty sure I'm out of time. Thank you very much. And if you have any questions, please write to me or call me. Thank you.
Merci beaucoup, Christine. Thank you very much, Christine. Is there any question for Christine or in the chat? I don't see any. I may have one if there is no question. No, I have one very naive. Just before that meeting, I was in another meeting, and the Geological Survey in Calgary, the office, they are leaving the office because it's the smoke is it's too dense. So people are going back home. I was wondering, I know that it's not burning exactly on your site, but can we use that that smoke as a marker to fine-tune your model? Can we see it? Can we see some indicators some days after in the stream? I don't know. It's just a very naive question. I'm not from that domain.
In this stream, I have no idea, but this will have an impact, that's for sure, on vegetation.
Yeah.
I'm not sure how and to what degree, and I think nobody knows for the moment how it will evolve, but it will have an impact, and to the point that I don't even know if Haley will be able, or student, MSc student will be able to study these sites because, or we'll have to change the subject, or let's say modify it a little bit because it won't be the same. So